Okay, now I will continue. Um, Now I will do some problems based on the continuous function. Let me do this problem, right? Exercise. Prove that the function f is defined on 0, comma 1. The function f defined on 0, comma 1 by, okay, f of x here, cube root, right? X. If x belong to rational number, if s does not belong to rational number, mean uh, otherwise you will write complement. Okay. Is continuous only x equal 0 and x equal 1. You know, it is continuous only x equal 0, x equal 1. Therefore, you want to check case by case whether this continuous or not at the point x equal 0 and x equal 1. Other point, you want to show the inner things also there. Other points, you expect this 0 and 1, the function is discontinuous. Okay. There are three claims you want to show that. You want to prove that there are three claims. Suppose this function f is continuous. First claim is function f is continuous x equal to 0 for this each cases, and x equal 1, the function is continuous for each cases. And also you want to show that other points, expect 0, comma 1 is not discontinuous. Okay, it is the question, right? Here they may be, they can change here 1 and 0 and 1, and also they can change these functions. Then same idea you can do, right? Okay. Case 1. First, I prove that this is continuous only, is continuous s equal to 0 case. So, case 1, you take the point x belong to q, the rational number, x belong to rational number. Therefore, what about this values, f of x minus f of 0, right? F of x minus f of 0 equal to modulus of f of x equal to, for x belong to q case, x. Okay. Now, before that, you do to this question, before that, first of all, you want to understand, right? F is continuous if and only if for all epsilon greater than 0, the Rx delta greater than 0, such that f of x minus f of a less than epsilon, right? For all x satisfying modulus of x minus a less than delta. It is very important, right? It is a definition for the continuous function because we use often here, right? These definitions. See, simply for a continuous function, we can denote it by CTS. It is called as a continuous function. Okay, right now, your claim is you want to show that this condition f of x, now your a is 0, therefore f of x minus c f of 0 less than epsilon, your claim. You can use this factor. For all x satisfying this condition, you can use it. Okay, now choose, right? Then, okay, choose here you put delta 1 because there are so many cases you want to check. Therefore, you put delta 1 equal to epsilon. Always epsilon obviously positive because here epsilon positive, right? Therefore, then what about your f of x minus f of 0? This is your modulus of x, right? This is your modulus of x. right? Since you have, or since we have, right, we have the condition, right, f of x, this one, um, we have for all, x satisfying which condition? X minus 0, that point A is 0, less than delta. From this one, we come up with this one, modulus of x less than delta. Now, this modulus of x less than delta. What's the thing you want to show that? You want to show that this is less than epsilon. Therefore, you want to choose delta 1 equal epsilon, delta 1. Delta 1, delta 1. Okay. You want to show that delta 1 equal epsilon, then suppose from this one, f of x minus f of 0 less than delta, sorry, less than modulus of x, equal modulus of x, but this equal modulus of x less than delta 1, we choose delta 1 equal epsilon, then you get the required form. F of x minus f of 0 less than epsilon. This is your claim, right? This is your claim. Now you prove this claim. That means since epsilon greater than 0 be arbitrary, right? Therefore, for all values of epsilon, that the result is true. That means you will write for all epsilon greater than 0, there exists delta greater than 0 such that f of x minus f of 0 less than epsilon for all x satisfying condition x minus a less than delta. This one, if and only if, this one means limit of f of x s length to 0 equal f of 0. This means f is continuous at x equal to 0. Therefore, f is continuous at x equal to 0. Okay, f is continuous at x equal to 0. It is for the case 1. That means x belongs to rational number. Now you want to do the case 2. That is for the case that is for the irrational number, right? Rational number. Rational number for the f of x equal to cube root of x. For that one, you want to check that is continuous. For that one, you want to prove that f is continuous at x equal to 0. Okay. Case 2. This only mention that you want to prove that f is continuous x equal to 0 and x equal to 1 only. Other points discontinuous. You want to show that one also. Case 2, let x belong to, if x belong to irrational number, then what are your values for this part? F of x minus f of 0. Here, cube root of x minus 0. Okay. Simply you can denote by this one as 1 by 3. Here you want to choose the delta. Choose delta 2. Delta 2. Just wait, right? I will try this formula for the delta 2 values. Then modulus of f of x minus f of 0 equal cube root of this x. Okay, for all x satisfying which condition? Modulus of x here 0, a less than delta. Therefore, modulus of a less than delta. Therefore, from this part, suppose you take the power 1 by 3, then this one delta over 1 by 3. Delta over 1 by 3. But you want to show that this one equal to epsilon. Then what is the value for delta 2? You want to choose delta 2. Delta 2. Delta 2. What is the value of delta 2 you want to choose? You want to choose epsilon cube. It's obviously positive. Epsilon cube. Okay, epsilon cube. Okay, right. Now from this f of x minus f of 0, f of x minus f of 0, let's wait. Okay, f of x minus f of 0. Here, your f of x equal to x 1 by 3 or square root of x minus 0. Then you have x 1 by 3. Here, x 1 by 3 less than delta 2 1 by 3. Delta 2 1 by 3. Now it's unequal to choose here. Choose delta 2 equal epsilon cube. No, therefore you put epsilon cube 1 by 3. You will get epsilon. That is your f of x minus f of 0 less than epsilon. Since here epsilon is arbitrary, epsilon considered to be arbitrary, therefore this result is for all n, right? Sorry, this result is true for all epsilon values greater than 0. That means for all epsilon greater than 0, there exists delta greater than 0 such that f of x minus f of 0 less than epsilon for all x satisfying modulus of x minus a less than delta. That is limit of f of x equal f of 0 s lends to 0. Right. Therefore, for a case 1 also continuous, case 2 also continuous. This means f is continuous at x equal to 0. For this case also, f is continuous. That case also, f is continuous at the point x equal to 0. Therefore, we can tell now f is continuous, right? F is continuous at x equal to 0 for these two cases. Okay. From we choose the delta for a minimum values. Choose delta equal minimum of delta 1, delta 2, then you can tell it is f is continuous at x equal to 0 for these two cases. Okay, because we assume that here delta 1, here delta 2. For in the last we will tell for these two cases, suppose here f is continuous the rational number, f is continuous irrational number at the point x equal to 0, therefore we choose that delta equal to minimum of delta 1, delta 2, f is continuous at x equal to 0. Okay, now we will write that part and we end up with this proof to the x equal to 0, right? Therefore, now, okay, therefore, choose delta equal minimum of delta 1, delta 2. Then for all epsilon greater than 0, the Rx is delta greater than 0, such that for each cases, for two cases, f of x minus f of 0 less than epsilon, for all x satisfying x minus 0 less than delta. X minus 0 less than delta. This means, right, f is continuous at x equal to 0. Here, x is with a rational number or irrational number, x equal to 0 case, f is continuous. Okay. The first claim we proved. Right now, we move to the second claim. Second claim, you want to show that at x equal to 1, this function is continuous. Okay. At x equal to 1, this function is continuous. You want to show that. Okay, now okay, let epsilon greater than 0 be arbitrary. Now, for x equal 1 case, no? Therefore, now you, first you write this factor, f of x minus f of 1. F of x minus f of 1 means modulus of f of x plus x, x minus 1. F of 1 means 1 for the rational number. If x belongs to rational number. Here, for the irrational number, you have x power 1/3 minus 1. If x belongs to irrational number. Okay. Now, you want to check case by case. First, you want to know that this one continuous and this one continuous. Case 1. Case 1. Let x belong to rational number. Then what about your f of x minus f of 1? It is x minus 1. You want to show that this x minus 1, here you have a is 1 now. Therefore, you want to think about this one, f of x minus a is 1, therefore f of 1, you want to show that this one is less than epsilon, but you can use this factor for all x satisfying here x minus 1 less than delta, right? Since for all x satisfying, right, for all x satisfying which condition x a is 1 now less than delta 1. First case you choose delta 1 because there are some cases we want to check. Therefore, suppose this one less than delta 1. Now you want to show that this one less than epsilon. No, therefore you want to choose delta 1 equal epsilon. Then you will get f of x minus f of 1. This one less than delta 1. This one equal to epsilon. That means, right, less than epsilon, right? Okay. Now, since epsilon greater than 0 be arbitrary, therefore this result is true. true for all epsilon greater than 0. That means for all epsilon greater than 0, there exists delta 1 greater than 0 such that modulus of f of x minus f of 1 less than epsilon, right? For all x satisfying which condition? X minus 1 less than delta, right? For all x satisfying x minus 1 less than delta. Therefore, this means, right? This means if and only if f is continuous at x equal to 1 for the case 1. Okay, right. Now we move to the case 2. Case 2, let x belong to complement. Then your f of x minus f of 1, what is the value? X power 1 by 3 minus 1. Okay, this one you want to show that this one less than epsilon. That is your claim, right? This one less than epsilon. That is your claim. Here we do some more steps because this question a little bit. Is it okay? Is it okay? Because x minus 1 you want to factorize, right? Because, right, okay. Why I use this factor? Let me check that one first. Right, I suppose you have this x minus, you can roughly work it out. Okay, x minus 1, you put here cube, so sorry, 1 by 3 into cube, then you have x 1 by 3 minus 1, x 2 by 3, x plus 1. Therefore, this is the formula, right? This is the formula. Here x minus 1. Therefore, for x minus 1 over this value is equal to s cube x 1 by 3 minus 1. X 1 by 3 minus 1 equal to x minus 1 over this values, right? X minus 1 over this value. Okay, x minus 1 over that values. Okay, now this one less than equal, is it okay? We can write, no? Suppose for two factors a plus b, the Young inequality less than equal modulus of a modulus of b. Like that for three variables. Okay, we will write. Okay, this factor. Okay, now right now repeat. Take more step here. Right. Now you have first for a delta, if first you choose 0 less than here for all x satisfying which condition? X minus a less than delta, right? X minus a less than delta, no, delta 2. X minus a, here your a is 1, therefore you put here x minus 1. First you choose some values for delta. Delta obviously greater than 0, you can choose any values. I choose now 7 over 8. Don't worry about these values, you can choose any values, right? But the value should be positive. 1 also you can choose it, 2 also you can choose it. I use these values. Okay, then what about this? If you release the modulus, we get minus 1 plus 7, 8 by 1 over 8. I think 1 over 8, x less than 15 over 8. Is it okay? 1 over 8, 15 over 8. Okay, 1 over 8 and 15 over 8. Right, now, so modulus of x 2 by 3 modulus of x plus 1. This values this less than sorry, this one greater than. You put the smallest value, then this factor should be greater, no? Therefore, you put 1 over 8. 1 over 8, 2 by 3 plus x 1 over 8 plus 1. If you add these things, you get it's 2 cube, no? 2 cube means 1 by 4 plus 1 over 8 plus 1. 8 is common for 2, then 1. 2, 1, 3, and 8. 3 and 8, 11. Sorry, here 1 by 3. 1 by 3. Oh, yeah. 1 by 3 is factor there, no? 1 by 3. Right. You know, the factors, sorry, that I here is x minus 1, we will write x 1 by 3 minus 1. You got right here x 1 by 3 cube minus 1. You can factorize, you know, this one. X minus 1, we will write x 1 by 3 cube minus 1. You factorize this one, you get 1 over 3 minus 1, x 2 over 3, x 1 over 3 plus 1. Okay, x 1 over 3 plus 1. Is it okay? X 1 over 3 plus 1. X 1 over 3 plus 1. This factorize this part, you will get this part. X 1 over 3 minus 1, x 2 over 3, x 1 over 3 plus 1. So you have 1 over 3 you factor here. Therefore, 1 over 3 means it's 2. Then 4, yeah, 4 and 2, 6, 7. Therefore, 7 by 4. 7 by 4. So, right, so now your f of x minus f of 1. Right. Now we move to that place. 7 by 4 no. Therefore, suppose you put this value, right? Suppose here less than equal 1 over this value means now this greater than this value. 1 over this value means less than 7 by 4. Less than 7 by 4. Therefore, 7 less than 7 by 4 x minus 1. 7 by 4 x minus 1. Is it okay? 7 by 4 x minus 1. If our condition is for all x satisfying 0 less than, sorry, for all x satisfying x minus 1 less than, right, x minus 1 less than 7 over 8. X minus 1 less than 7 over 8. Okay. Okay. Now we choose for delta one of the minimum values because you want to show that this one epsilon, this one equal epsilon. You already have this modulus of x minus 1 should be less than delta, no? Now we have 7 by 4 into delta. Here we use delta 2. Okay, delta 2 because for all x satisfying this case x minus 1 less than delta 2. X minus 1 less than delta 2. Therefore, for delta we have two values. First value is 7 by 8 and another value is, here we assume that value is 7 by 8, no? Now another value delta 2. Therefore, you want to choose for delta 2, right? For delta, yeah, for delta you want to choose one of the values, minimum of, right? Minimum of which value? This value right? And this value. Therefore, under that one, under this one, you will continue here. Very quick question here. Delta 2, okay. Choose, because you want to show that this one equal epsilon. It's an equal epsilon. For this, choose delta. Now we put delta 3 equal minimum of. Here, OD, you choose the delta values here, 7 by 8. 7 by 8. Right. Now, what is the value for here? To choose delta 3. Because you want to get here equal epsilon. You want to get here equal epsilon, no? Then what is the value for delta 2 we use here? We have 7 over 4 delta 2 equal epsilon. Then what is the value of epsilon? Epsilon equal, what is the value? 4 epsilon over 7. If you choose this one, you will get less than epsilon. Okay, right. Now, choosing this delta 3, then you have f of x, f of 1 less than epsilon for all, because here choosing this, here at this point here, this one less than this one, 7 by 4 delta 2, 7 by 4 delta 2, you use 4 epsilon by 7, you get epsilon. Therefore, f of x minus f of 1 less than epsilon. Therefore, less than epsilon. Okay, less than epsilon. Right, for all x satisfying which condition? X minus 1 less than delta 3. Okay, therefore, since epsilon greater than 0 be arbitrary, therefore this result is for all epsilon values epsilon greater than 0, there is delta greater than 0, such that here delta 3, such that f of x minus f of 1 less than epsilon for all x satisfying x minus 1 less than delta 3, right? X minus 1 less than delta 3. Therefore, in this case, the irrational number also, f is continuous at x equal 1. The irrational number also, f is continuous x equal 1. For the case 1, for the x equal 1, for a case 1 also continuous, case 2 also continuous, since we choose the, right? Okay. Now we erase this one. Since we choose the delta again, choose again delta minimum of, in this case we choose first delta 1, okay. Second case we choose delta 3, for the minimum we take, then you will prove that. Then you can say that for a minimum of delta 1 comma delta 3, for all epsilon greater than 0, the direct is delta greater than 0, such that f of x minus f of 1 less than epsilon for all x satisfying modulus of x minus 1 less than delta. Therefore, f is continuous at x equal 1. For the rational number or irrational number, both cases are continuous. Okay, now we prove x equal 0 is continuous and x equal 1 is continuous. Two things we prove. Last claim, you want to show that other points, expect this 0 and 1 is not continuous. That means discontinuous points. Okay, we will prove that part next. Let's claim f is not continuous. That means discontinuous. F is discontinuous Okay, discontinuous at x does not take the value 0, 1. Okay. For that's one. Let you take a one of the point, but not equal 0, 1. Another arbitrary point. Be arbitrary point. Right. Then is it okay? A belong to rational number intersection 0, 1. We take two intersection interval and you know, uh, um, there are two possibilities. 2a here because your interval here you want to show that this function is here 0, 1 your function exit. Very important this one. 0, 1 is function exit. But at that point you already proved that this one continuous, this one continuous. Now you expect these 2 points, you have the open interval. Zero, 1. Here so many rational number there, irrational number there. Therefore, for this part here, rational number there, irrational number there. For this way, for this one, for in the interval, you can choose one of the number A. X belong to rational number intersection 0, 1 means A belong to rational number and A belong to open interval 0, 1. Is it okay? It's okay. Understand? Because they asked to prove only contains 0, 1, okay, but they already gave the interval. In that interval, you want to check other points discontinuous. Only 0, 1 is continuous, other points discontinuous. Therefore, it is your interval. That's why we take this this set here. Rational number intersection 0, 1. So here, in this case, is one of the case. Another case, A belong to rational complement intersection 0, 1. Because here, irrational number also there. Okay, right. Therefore, we want to check it by these two cases. For these two cases also, this function is discontinuous. That is your claim. Okay. Case 1. A belong to a rational number intersection 0, 1. Since you know it is okay. For all n belong to natural number. Since is it okay? Right? N belong to natural number. Okay. Then such these two elements, a minus 1 over n there, a plus 1 over n there. Here you can find one of the irrational number. Irrational number in this inside you can find there like this. Then irrational number you can call it that number an such that a minus 1 over n less than a plus 1 over n for all n belong to natural number. Okay, it is the irrational number, right? It means a n belong to this give complement. Okay. From this one, you will write, from this inequality, you will write an minus a less than 1 over n for all n belong to natural number. Now, suppose n length infinity, we have a n length to a as n length to infinity, n belong to natural number. But what about this f of a n values? Because now we use one theorem, we already know that, right? Suppose this theorem. F is continuous at x equal to a if and only if there exists a sequence Sn in a domain A such that Sn lends to A as n lends to infinity. We have here Sn not equal to A, not equal to A. We have f of xn lends to f of A as n lends to infinity. F of xn lends to f of A as n lends to infinity. One of the theory parts, right? That one. Now we use that one. F of an. What is the value of f of an? Here your an is irrational number. Very careful. An is irrational number. An is irrational number means your function take the value square root of x. Now you take the limit for this one. F of an n length to infinity. Suppose this continuous means this value is equal to f of a. What is your f of a? F of a, just wait, right? This limit of n length to infinity an, right? An, right? Square root of an 1 by 3. You already know that an length to where? A. Therefore, this value is a over 1 by 3. A over 1 by 3. If f is continuous, what about this f of a values? F of a values. F of a values mean a belong to rational number. A belong to rational number. Therefore, a belong to rational number means you take function, take the value. Suppose here you put a, therefore f of a equal a. Rational number no a. Therefore, f of a equal to a. But here not equal to a. Suppose this value is also a power 1 by 3, f is continuous. Here a 1 by 3 not equal to a. Therefore, in this case, f is not continuous because this theorem not satisfying. F of xn does not lend to f of a. Therefore, f is not continuous. Right? Therefore, f is not continuous at, right? F is not continuous at a, right? At x equal a. A is belong to this condition. Right? Now another case, case 2, case 2. At case 2, case 2, here you are, now your A belong to rational complement intersection 0, 1. Like that you can choose since, right, since a minus 1 over n, a plus 1 over n. Now your a is irrational number because a belong to rational, irrational number, Q complement, and a belong to 0, 1. Okay, right. For this one, at these 2 points, a minus 1 over n, inside a there, a plus 1 over n. You can find some number, right? Find some sequence number a n that one belong to irrational number. That one belong to irrational number. Therefore, they are like this irrational number. They are rational number. Rational number. First case you find the irrational number. Now this case rational number. Rational number, right? A n such that, right? Right here a n is a sequence of rational numbers, right? Sequence of rational numbers. Sequence of rational numbers such that a minus 1 over n, a n, a plus 1 over n. Okay. Here for all n belong to natural number. For all n belong to natural number. Therefore, from this one implies your a n minus a less than 1 over n for all n belong to natural number. This one implies a n lends to a as n lends to infinity. Right? A n lends to a as n lends to infinity. A n lends to a as n lends to infinity. Therefore, what about this f of a n value? Here your a n is rational number. A n is, where is a n? Here a n is rational number. A n is rational number means f of a n equal a. F of a n equal a. Then now you take the limit f of a n lends to infinity. Limit of, right, limit of f of a n lends to infinity. Suppose f of a n equal a n, but a n lends to infinity, a n should be a. What about your f of a? F of a means here a is irrational number. A belong to irrational number. A belong to irrational number means f of a equal to square root of a. That means a 1 by 3. Therefore, it's not equal to a 1 by 3. Both are equal then continuous, not equal. Therefore, it's not continuous. Therefore, if is not continuous, at a discontinuous. Okay, discontinuous at x equal a. Okay, now we prove all claims. We prove here. First claim x equal 1 is continuous, x equal to 0 is continuous. For other points, it's not continuous. This is the question, right? Okay. Okay. Okay, I will stop here, right? I will stop here and I can do more questions, right? Based on the continuous function, right? And also other parts, right? Would you follow these examples and you can easily do more questions, right? You can do any question, right? Like this, okay? Only I did some examples, right? Exercise, right? Theory parts you want to study, then you can perform that one, okay? Okay, but I will tell the theory parts. I already recall some theory parts, right? You can check the theory parts. Sit there in the calculus, okay?